good morning. Since we don't have any actual classes for today, so we're gonna have it online. So this is just gonna be a recording. I'd expect you guys to watch this video today, tomorrow, and over the weekend, and expect on Monday to have a very similar bell ringer that you guys will have to answer by Monday. So let's try to answer like about four problems today that involves trigonometric functions. So let's begin with example number one. So a boy flying a kite lets out 300 feet of string, which makes an angle of 38 degrees with the ground. Assuming that the string is straight, how high above the ground is the kite? So we are going to start with our diagram. So for our diagram, we are going to be creating here's a kite flown by a boy that has a string that's about 300 feet. So let's just assume that the string, according to the problem, is creating a straight line. Now, it creates an angle with the ground of about 38 degrees. So let's say this is just going to be our angle. Let's just consider this as our angle of 38 degrees. And we're being asked how high above the ground is the kite. So this is the distance from the ground to the kite. And that is what we are being asked about. So we now have our diagram. So our next part is we are going to create our solution. Now, let us first try to understand what is given. So we are given an angle of 38 degrees in reference to the ground, which is what we have right here. Our hypotenuse is also given, which is equal to 300 feet. And we are being asked for our vertical distance from the ground to our kite. We can just, that would definitely be our opposite side in relevance to over 38 degrees. So that will be, let's just call that as our y. So going back to our three trigonometric functions, we have our sine, which is equal to opposite over your hypotenuse, your cosine, which is equal to your adjacent over your hypotenuse, and your tangent, which is just equal to your opposite over your adjacent side. Now, if we take a look at the given and what is required of us on our problem, we have your hypotenuse and our opposite side. So in this case, we have our sine function that we could use in order for us to solve for the vertical distance of the kite to the ground. So we could say sine 38 degrees is equal to our opposite side, which is y, over our hypotenuse side, which is just equal to 300 feet. Now, we're looking for our y, so we need to get y by itself, and we can do that by multiplying 300 feet on both sides. And that will cancel out our 300 on the right side of our equation, giving us 300 multiplied to sine 38 degrees is equal to y. So we can do that on our calculator. So this is an emulated calculator that is exactly the same as the buttons of our calculator back on the classroom. So let's just try to do that. So we start with 300 and we multiply that to sine 38 degrees. Let's try to close that with our close parenthesis. And a quick reminder that our mode has to be in degrees. If your calculator is in radians, so you need to change that mode to degree. So we are just going to press enter in order for us to find the value of our y. So according to our calculator, it should give us about 184.698, or we could just have it as 184.70 feet. I'm just going to box that, and we can now write our statement as the kite is about 184.70 feet from the ground. And we are done with example number 1. Okay, example number 2. A ladder leaning against the wall makes an angle of 74 degrees with the ground. If the foot of the ladder is 6.5 feet from the wall, how high on the wall is the ladder? So first thing that we want to do is we create our diagram. So we have here a wall and our ladder on the side. And the distance of our ladder from the wall is about 6.5 feet. Okay. And we're being asked how high on the wall is the ladder. So this is our wall. So we're being asked for this side. Let's just label that as y. Our angle in consideration is also our angle of elevation, which is on this side. And that will give us an angle of 74 degrees. So let us proceed with our solution. So we do know that the angle in consideration is 74 degrees. Our adjacent side is also given as 6.5 feet. And we're being asked for the opposite side, which we do not know. We can label that as y. Now, if we try to review again our three basic trigonometric functions, we have our sine, which is opposite over your hypotenuse. Your cosine is your adjacent over your hypotenuse. And your tangent, which is equal to your opposite over your adjacent. Now, if we try to take a look at our given and what is being required of us, we have your adjacent side and your opposite side, which is just equal to our... Bye, guys. Let me just bring that up just a little bit. Here we go. So again, that will just give us a tangent function. So we can just therefore say we could proceed with tangent 74 degrees is equal to the opposite side, which is our y, over our adjacent side, which is 6.5 feet. Now, we're looking for our y, so what we need to do is we need to multiply 6.5 feet on both sides. Okay, and this one will cancel out 6.5 on the right side. So we now have 6.5 feet multiplied to tangent 74 degrees. So let's use our calculator. So we could use 6.5, multiply that with tangent 74 degrees. We press enter, and that will now give us about 22.668, or that would, we could just round that off with 22.67 feet. So therefore, this one will now just give us, okay, sorry for that. Our board seems to keep on moving. So again, guys, so that is just going to give us 22.67 feet. So that's our answer, but we need our statement. So the ladder is 22.67 feet on the wall. Or we could also include high on the wall. So that's example number 2. So let's try to do example number 3. So a straight road to the top of a hill is 200 feet high, which is 3,000 feet long. So find the angle the road makes with the horizontal. So let's create our diagram. So in context as an engineer or for somebody who makes roads, let's say we have an incline of about 200 feet. Just arrange my, here we go. So I'll create, so we have here an incline of about 200 feet. Let me just check if this is still a pencil. Yeah. So this one was supposedly give us an incline of about 200 feet. Now, the actual load or the actual road is about 3,000 feet. Let me just try to increase this just a little bit. So again, guys, so this is about 3,000 feet. Okay. Take note that if somebody tries to create a road, okay, even if the elevation is 200 feet, we don't want to create a road that is going to be very, very steep. So we want to keep it at an angle, which is just right for a regular automobile, a regular driver to be able to cross that road from an elevation of 0 all the way to an elevation of about 200 feet. Now, we're being asked for an angle this time. So this time, the angle is not given. However, we are being asked for our angle. So let's just try to call this as angle theta. So again, guys, that's the road. It has an elevation of about 200 feet. The length of the road is 3,000 feet, and we're being asked for the angle of elevation. So how do we solve for this one? So again, we already have our diagram. So let us now try to look at our solution. So the solution for this, let's take a look at our given. This is our angle in consideration. So we're being asked for the angle. Let's try to call that as angle theta. The opposite side is about 200 feet. Our hypotenuse is 3,000 feet. Okay, so going back, sine is equal to your opposite over your hypotenuse. Cosine is equal to your adjacent over your hypotenuse. Your tangent is equal to your opposite over your adjacent side. So in this case, we have your opposite and your hypotenuse. So therefore, we can use sine theta is therefore just equal to the opposite, which is 200 over 3,000 feet. Okay, so this is now our actual equation. So how do we do this on our calculator? So let's go grab our calculator. So this one is relatively easy. So all we need to do is do this first. Divide 200. Divide that with 3,000. Okay, we press enter. So we will arrive at 0.066, so 66 bar. And take note, that's not yet our angle. So all we need to do is, since we're gonna be using our sine, so we're gonna get the inverse of sine. So we press the blue button on our calculator, the second function, press sine, then we press our answer. Okay, I accidentally pressed the enter. My bad, guys. So let's try to do that again. So again, sine, second function, sine 0.0667, and that should give us our angle of about 3.82 degrees. So therefore, our theta, or our angle, is just about equal to 3.82 degrees. So our final statement will give us the angle of elevation is 3.82 degrees. And we're done with example number 3. Okay, so let's begin with the fourth example. So an airplane climbs at an angle of 11 degrees with the ground. Find the ground distance it has traveled when it has attained an altitude of 400 feet. So let's create our plane. Plane is already on top. I don't know if I could create a really good plane with a wing. Okay. So according to our problem, it already has an altitude of 400 feet. Okay. And we want to find out the ground distance that it has traveled. So we're looking for this part. This is like the angle of our airplane. That's gonna give us an 11-degree angle. So this is our diagram for today. That's an airplane. It already has a vertical distance with the ground of about 400 feet. And we're being asked for the ground distance it has traveled. So this part right here. Okay, our it's moving again. It does kind of move a lot. So anyway, so let's solve. So let's take a look at our solution. So this is our angle. So our angle is 11 degrees. The adjacent side is what is being asked. Let's just try that as x. And our opposite side is equal to 400 feet. So again, going back, guys, try to remember the abbreviation of SOHCAHTOA. Let me just, it does want to keep on moving, but hopefully, here we go, SOHCAHTOA. So looking at our given and what is required, we have your adjacent side and we have your opposite side. So therefore, we are going to be using our tangent function. So we do tangent of 11 degrees is equal to the opposite, which is 400 over x. Now, we're looking for our x. What we can do here is just try to cross multiply your tangent 11 with your x. So if we cross multiply this two, this is going to give us our working solution right away. So this is just going to give us x is equal to 400 tangent 11 degrees. So let us now try to do that on our calculator. So that will now give us 400 divide that with tangent 11 degrees. That's going to give us an answer of 2057.82 feet. So we can say now that our total distance traveled is 2057.82 feet. Our statement will now give us the plane has traveled a ground distance of 2057.82 feet. And we're done for today. So tomorrow, guys, I won't be here, but you guys can still continue work with your spaghetti bridge. Kindly keep the class clean after you guys are almost done. And see you on Monday. So again, expect a bell ringer with any of these four examples that we have discussed for today. Thank you.